Okay, in this lesson we're going to talk about an introduction to limits. And so we're going to start off with considering just a function here. Our function is f of x equals x squared minus 4 over x minus 2. Now let's just think about this for a second. If we wanted to take a look at this graph, we could plug that right into the TI-84 calculator and see what that graph looks like here. But this graph is a little bit deceiving. It looks like this is just a straight line right here that's continuous. But we know that if we think about the domain of this function, x cannot equal 2 right here. So at 2, we actually have a hole in the graph, even though the calculator doesn't really show it there. But suppose that we wanted to know what happens if x gets close to 2. If we wanted to talk about what happens if we get close, what if we get kind of close to 2 coming from this way? Or what if we got close to 2 coming from this way? What happens here with this function? And we can see that if we get close to 2 coming from this way, we get closer and closer and closer to some number up here. And the same thing happens if we come over here from the right. So although we couldn't talk about what happens here when x equals 2, we can talk about what happens when x gets close to 2. And that's exactly what happens when we are dealing with limits, is we're talking about what happens as x gets close to a number, what does that y value get close to? And so there are some different ways that we could approach that. One way is that we could do this numerically. We could say, okay, well, what happens if x equals 1.9? Well, I can go in here and see what that is. I can use my calculator. I just got my function inside my calculator here, and I'm going to go into my table and see what happens if I put in 1.9. Well, 1.9 gives me a value of 3.9 as my y values. So I've got 3.9 for my y value. What about if x equals 1.99? Well, then my y value is 3.99. If x equals 2.1, I can see I get 4.1. And if I plug 2.01 in, I'm going to get 4.01. And I can see what's really going on here is that the closer I get to 2 here with my x values, the closer this seems to be getting to the number 4. And I can do it the other way around, right? Here I'm getting closer to 2 coming from the right here. And this also seems to be getting closer to 4. And I can see it over here with the graph. The closer I'm getting to 2 with my x, the closer these numbers seem to be getting to 4. Or if I look at it coming from the right, the same thing happens. And so what happens here is I can say that that the limit as x approaches 2 of my function, which is x squared minus 4 over x minus 2, the limit as x approaches 2 is equal to 4. And I've just done that numerically over here, and I've kind of taken a graphical approach as well. So, our notation here for this is that when we write limit as x approaches c of f of x, if that equals L, this means that as x gets closer and closer to c, then f of x gets closer and closer to L. Now, the easiest way of doing this is to do something like just see if you can just plug this value in. In many cases, we can just plug that in. If it doesn't cause any problems, then it's just a matter of evaluating that. So in this case right here, this limit is equal to, let's see, the limit as x approaches 5 of x squared minus 5. This would be 5 squared minus 5. Looks like that's going to give us something like 20. Well, what about something like this? As x approaches 0, we have the absolute value of x over x. We want to see, well, what does this do? Now here, we have to think about what's happening as we say we are getting closer to 0. There's a couple of ways we can get closer to 0. What if we try to do just substituting it in here, if we just try to put 0 into here, we see that we get a 0 in the denominator, which is of course something we're always trying to avoid. And so we know that this substitution method doesn't really work in this case. And so let's just kind of think about it from some other point of view. What about if we get closer to 0 coming from the left? So those would be really small negative numbers. And so we got really small negative numbers and we approach 0. So let's think about something like, I don't know, negative 0.1. If I put negative 0.1 in here, the absolute value of that would be 0.1. Negative 0.1 would give me negative 0.1 down here. Dividing those would end up giving me negative 1. And in fact, that's what would happen for any negative number. I can see that in the graph down here. If I'm approaching 0 coming from the left, then all I've got down here is I've got negative 1 as my y value. If I approach 0 coming from the right, then I would end up with 1 when I plug all those numbers in here. And so what happens is I get a jump right here. I get a place where there's a gap in this right here. There's no way to reconcile that. And so getting close to 0 in this case and saying, hey, well, you know, if x gets closer to 0, what is this approach? It's impossible to do in this case because it's approaching different things coming from different directions. And in this case, we would say that this limit does not exist. And that kind of leads us to something that is a general principle with limits. It's got to approach the same thing coming from both sides for that general limit to exist. So let's look at another example. What about in this case? We have the limit as x approaches 1, and our function is 1 over x minus 1. Again, well, maybe I'll just forget about the graph for a second. If I just tried to plug 1 into here, I end up with something that's a problem. I end up with a 0 in the denominator, which again is something I always try to avoid, and so I can't really do that. So let's take a look at the graph and see if maybe we can get somewhere from there. Well, here's 1, here's x equals 1, and if I'm approaching 1 coming from the left, I can see that this thing is heading down towards negative infinity. And if I'm approaching 1 coming from the right, then the y values here are heading up towards positive infinity. So again, we have, like we did in that last example, coming from both directions, they're going to different values. I mean, in the extreme case here, right? Because one's going to negative infinity, one's going to positive infinity. And so again, here's an example where the limit does not exist. That general limit only exists if they approach the same thing coming from the left and from the right. Well, let's consider one more example. Here, let's consider this example where we're going to evaluate the limit as x approaches 1 of f of x, and f of x is defined this way here. It's defined to be x minus 3 if x is less than or equal to 1, and it's defined to be 5 if x is greater than 1. So let's approach this. Let's see what happens here when x approaches 1. Now, if we're approaching 1 coming from the left, we're coming in this way, and those would be values that are less than 1. So if x is less than 1, then the function is defined this way up here, x minus 3. And as x gets closer and closer to 1, this up here gets closer and closer to negative 2, right? 1 minus 3 would give me negative 2. If I'm approaching x coming from the right, then I'm talking about values that are a little bit more than 1. And if x is more than 1, then this is how the function's defined. And so I can see once again that I end up with different y values as I'm approaching 1 coming from each direction. And so again, here we have an example where the limit does not exist. And again, the limit only exists if when we approach 1 coming from both directions, you end up with the same value. So I'm giving you a lot of examples here of where those limits don't exist. And that's really because, you know, those are the things to kind of watch out for. When is it that we end up with limits that just you can't work out? Let's look at one more example. All right, here we have the limit as x approaches 3 of the square root of x minus 3. And again, let's kind of cover up the graph and just kind of think about this algebraically for a second. Our first strategy is always to try to go in there and just plug the number in. All right, so if I try to plug in that number and see what happens, I could put 3 in here, and I get 3 minus 3 gives me 0, and the square root of 0 is 0. So it kind of seems like things are okay here. But we always have to consider what's happening as we're approaching 3 coming from both sides. And so if we approach 3 coming from the left, then we're talking about numbers like 2.5 or 2.9, numbers that are a little bit less than 3. And you can see that if you try to plug those things into here, you would end up with a negative underneath the square root. And those things, you just can't evaluate that in the real number system. We can see that by looking at the graph over here. If I'm over here to the left of x equals 3, then there is no graph because this function doesn't exist when I'm over here to the left. And so I can't even get a number for approaching from the left. I could get something if I was approaching from the right. You know, that's coming down here and getting closer and closer and closer to 0. But the one coming from the left, there is no limit there. There is no value. And so again, here's one of these special cases where the limit does not exist. All right, so the thing we're having to remember, sort of the takeaway point here is that when we're thinking about limits, an intuitive way of thinking about this is that when you're approaching that number, you got to think about it coming from both sides. And you're looking to see what happens to that y value. And if you don't get the same thing coming from both sides, then that limit doesn't exist. And it's perfectly fine to look at a graph or to plug numbers into the calculator and kind of see what happens there. There's other algebraic ways, and that's what we'll see here in the next video.